Hey everybody, and welcome to chapter 14, the big wide world of smell. So we're getting into the first of our chemical senses. So let's jump right into it. What we're going to be talking about in this video series is trying to establish what is smell, because one of the funny things about smell, just like light and vision and sound, is that we've been around smell forever, right? As far as we can remember, we've been able to smell, and so thinking about what it is that we're actually engaging with when we smell is actually kind of difficult, right? It's weird to kind of pull back and think about, starting from the beginning, what smell is and how we are able to sense it, which will take us into the anatomy of smell, and then we'll get to the brain. Just like in the previous chapters, we're going to talk about how we sense it and then how we perceive it. So moving all the way up to the brain, and then how the brain processes it. We'll talk about how humans smell. We're going to compare that with other non-humans. We'll talk a little bit about the theories of smell perception, and finally we'll talk about how we can communicate with each other through smell. So it's a lot of material. It's very broad. We're not going to go into too much detail about a lot of these things. Instead, we're going to kind of look at the field as a whole and kind of talk about some of the big parts of it, the most interesting parts of it. So let's get right into it. So smell is different than any other sense that we've talked about so far this semester. It's different from vision, it's different from hearing, and it's different from vestibular and from touch. But establishing why is because of the kind of sensory detectors that are used to pick up on smell. If we think about vision, vision was all about being able to detect different particles of light, right? And depending on those waves or those particles of light, what wavelength they are, we establish that as a color. So that's what we're detecting there. For hearing, we're detecting displacement. We're detecting vibration through a medium, and depending on that vibration, we judge how loud something is, or how soft something is, or how high pitched or how low pitched. With orientation or vestibulation, we talked a lot about kind of the detection of angles and orientation of movement for the head. And for touch, in chapter 13, we talked a lot about the detection of pressure, pain, temperature, and all these other things. If we wanted to look at it like this, we could say that hearing, orientation, and touch were all mechanoreceptors. Vision was electric, and now we're getting into a different kind of receptor. We're getting into smell. Smell is the detection of chemicals, specifically chemicals that are in the air. Next chapter, when we talk about taste, we'll talk about the detection of chemicals on the tongue and in the mouth, but we'll get there in the next chapter. Alright, so let's talk a little bit about what it is that we're actually detecting. What are these chemicals that are in the air? These are odorants. And so what an odor is basically the translation of taking this stimulus, this piece that is floating through the air, and recognizing it by detecting it with your sensory organ. So an odorant, so think of odor as kind of the perceptual aspect of it. The odorant is the stimulus. So you can think of it as kind of like, if you want to be very pedantic, what is the difference between these things? You can't really say that you smell an odor, because an odor is the process of translating whatever it is that you're smelling. Instead, you can say that you are smelling some odorants, or that the odorants smell badly, or you could say that it has an unpleasant odor. If you say that something has an unpleasant odor, what you're saying is that the perception of that particular smell is not very good, right? So it's a fine line, it's a very nitpicky difference, but there are differences in the terminology that's used in this chapter. So an odorant is going to be a molecule. It's going to be something that has very specific physiochemical characteristics that allow it to be smelled. What are those characteristics? Three main things. It needs to be volatile. In other words, it needs to be able to float in the air. That feels a little bit obvious, right? Because you might be smelling something right now because it's floating through the air. The second piece of this is that it needs to be small. Not only small enough to fit up your nostril, but small enough to bind on the specific receptors in your nasal cavity that are responsible for detecting smells and odorants. And finally, it needs to be hydrophobic. In other words, it needs to be repellent to water. That's going to come into play a little bit later because of how these molecules are going to bind on to the cells that are specifically interested in chemicals and odorants and things like that. All right, so basically you can kind of see how like these odorants, have their own kind of look, and that's going to come, or their own kind of shape, their own kind of physical properties. That is going to come into play in the next video when we start talking about the theories of how we smell. But again, we'll get there. We're being patient with this. So for now, let's just talk about how it is that we're able to actually detect these smells. It all starts with the nose, as you might expect. You know this because if you plug up your nose, you can't smell anything, right? But the function of the actual nose isn't really just for smelling. It's for breathing. It's for pulling in air. But pulling in air has the convenient byproduct of pulling in all these molecules with it, all these odorants with it, that we will then process. So the nose is almost kind of like how the ear is not really for hearing, right? The ear itself is not for hearing. The ear is more to, number one, kind of protect the ear canal, but also to funnel in the sound. The actual ear itself doesn't process sound, just like the nose doesn't process smells. But we'll get up a little bit further in there and we'll see where we are able to start detecting smells. So the olfactory cleft, this is going to be kind of this gap. It's a valley where it's a space up by, inside your nose and further back that is hollow. It's a cavity, and that is where our best friend for this chapter is gonna come into play. Our best friend for this chapter is the olfactory epithelium. The olfactory epithelium is going to be the primary sensory organ for smell. Let me say that one more time. The olfactory epithelium is the primary sensory organ of smell. What does that mean? The retina is the primary sensory organ for vision. The cochlea is the primary sensory organ for hearing. So it goes with smell. The primary sensory organ is the olfactory epithelium. So you can kind of think of this as the cochlea of smell. So the primary function of this is detection. And so this mucous membrane, you can kind of see an illustration of it right here, is this nasty, goopy kind of layer that different things are going to stick to for us to smell. But you can kind of see this cutaway where basically we got this guy, the inside of his face, mostly kind of hollow, made of a lot of soft tissue that's going to allow a lot of this air to flow inside his face. And so you can kind of see here in the olfactory cleft, which is just this big part up here, as these odorants go up, some of them are going to go up to the top because they're volatile and they're going to bind to the olfactory epithelium. Let's talk a little bit more about the olfactory epithelium. And after that, then we'll start talking a little bit about the olfactory bulb. So the olfactory epithelium, again, is the retina of the nose. It's the cochlea of smell. It's the primary sensory organ. And it is made up of 3 separate kinds of cells. The supporting cells, which are, as its name suggests, basically there to support the other 2 cells. These supporting cells are going to give these other cells energy. They are going to make sure that they stay powered. The basal cells, these are going to be kind of, here I say they're precursor cells. Basically, they start engaging with the odorants, but they don't actually do the detection themselves. They're more for mechanical reasons. But finally, the most important of these 3 is the olfactory sensory neurons, also called the OSNs. The OSNs are going to be the rods and the cones of the nose, or the hair cells, if we're talking about hearing, the hair cells of smelling. The olfactory sensory neurons are going to be the specific neurons that are going to detect these different odorants and discriminate what they are. So these small neurons are going to be located basically beneath that nasty goopy part of the olfactory epithelium. And so here in this cutaway diagram, you can kind of see it again, where you have, and so we're up here at the very top of our olfactory cleft, how we have these different kinds of cells. The ones that you should be really looking at are going to be the blue, the different colors. The pink ones are going to be supporting cells, and some of these back here that are keeping it all in a place are the basal cells. But the most important ones are going to be these neurons that have these dendrites that are hanging down. And so these little kind of tendrils, those are dendrites, just like every other neuron has. But what's interesting about these particular neurons is that their tendrils will actually bind onto these molecules. So normally, whenever we are talking about these dendrites, really what they're doing is they're looking out for other neurotransmitters, right? We're not dealing with that here. We're dealing with them actually picking up on foreign bodies, basically. Because if you think about, like, for example, if you smell brownies, what is it that you're smelling? You're smelling molecules, you're smelling odorants that are wafting through the air that originated from that brownie. So if you're cooking brownies, it's kind of, forcing parts of those molecules to be airborne, to be put into the air. So whenever you take a deep breath and you smell those brownies, you're basically getting tiny little brownie molecules up here in your olfactory cleft, where the olfactory epithelium is going to bind onto those and tell us what it is that we're smelling. And so these dendrites we're going to refer to them as basically kind of like cilium. So these dendrites have their own tiny little hair-like cells. They're very different from the other types of hair cells that we've talked about this semester. In other words, they're not mechanoreceptors. But they are going to be the things that really start here on the dendrite, connecting and telling the cell what it is it has just picked up, what it is it has just detected. All right, so from there, after it is processed, then we're going to move up to the olfactory bulb, which is this whole layer up here. And technically, the olfactory bulb is part of the brain, which means that we're done with the detection, we're done with sensation. Let's talk a little bit about perception. So what's going on our way to the brain? The first step here is going to be the olfactory nerves. So if you think about vision, we have the optic nerve, and we have, for hearing, we have the auditory nerve. We have the exact same thing for olfaction. For smell, we have the olfactory nerve, which is going to move from the olfactory epithelium up to the olfactory bulb. So these pair of nerves are just basically trying to get information from the top of your nose up here up to right above, your eyebrow, where the olfactory bulb is. Or, well, actually, that's not actually where it is. It's actually, the olfactory bulb is a little bit right around here below your eye-ish. So that's the olfactory nerve. The olfactory bulb, this is going to be part of your brain that is kind of sticking out just above the nose. That is going to be kind of, not exactly, but kind of like the V1 or the A1 for smell. It is going to be the first part of the brain that really processes this information, that really perceives what these OSNs have detected. So we have two olfactory bulbs, both on each hemisphere, or one per hemisphere, and they are ipsilateral. So in other words, they're not like touch, where you have, or vision, where you have cross-brain connections. If you're to plug up your one nostril, in this case my right nostril, and I inhale, whatever it is that I smell is going to go to my left over to my right olfactory bulb. So it's ipsilateral in that way. From there, it is going to start traveling to the primary olfactory cortex through the glomeruli, and the glomeruli, don't worry too much about this. The textbook goes into a little bit more detail about this. I don't really particularly care if you know all that much about it. The glomeruli are kind of, I don't want to call them excess, because people who wrote this textbook would be very upset if they heard me call it excessive cells. But don't worry too much about that. We're going to go from the olfactory bulb over to the primary olfactory cortex, which is going to include the amygdala, the parahippocampus, and the entorhinal cortex. And so that is really where we start combining what we have detected and what we have perceived in our olfactory bulb with other parts of our brain. So this is where it really starts to become integrated, the primary olfactory cortex. Now, those of you that are playing along at home, you'll see some of these things and you'll think, hey, the amygdala, that sounds really familiar. I feel like we talked about this in another class maybe, and you probably did. The amygdala is a very popular part of the brain. What does it do? The amygdala is really kind of used for emotion. It's really used for disgust. It's used for fear. All of these things you might think about as being closely tied to smell, right? Think about disgust. The feeling of disgust, that is something that is very salient for whenever you smell something that is disgusting, right? But just the opposite. Sometimes if you smell let's say that you have spent a long time away from home, and whenever you come back home, you open the door and you smell that smell of home. Even if your home does smell kind of crappy, it'll be familiar and it'll feel kind of comforting to smell that particular kind of smell, because the amygdala is used a lot in emotion. That's going to come up again both in this class and in cognitive psychology in that class if you choose to take it. The parahippocampal gyrus, also called the parahippocampus, is very closely connected to the hippocampus, so used a lot in memory. And the entorhinal cortex. The entorhinal cortex is generally the one that people aren't as familiar with. What is it? The entorhinal cortex is used a lot for very old school associations. So in other words, the entorhinal cortex is used for kind of like survival mechanisms that are related to creating associations. And so if you think about how all these things are combined together to create the primary olfactory cortex, you see a really interesting story, which is that basically when we smell things, that there is an emotional connection to it, that there's a memory connection to it, and there's an associative connection to it, that all these things are combined to give us very vivid emotional memories, right, from smell. And so there's a good reason why we feel very confident about memories that we have when we smell things, because of where smell is really processed there in the primary olfactory cortex. Okay, so that's all that I want to talk about for this particular video. I'm going to catch you again very soon by comparing our ability to smell with other species. See you soon. Bye.